During the Northern Song dynasty in 11th century China, Bishang, born in 990 CE, developed one of the most consequential technical innovations in the history of manufacturing, a system of reusable, interchangeable components for printing. Although the term interchangeable part is often associated with modern industrial production, its conceptual foundation can be traced to Bishang's invention of movable type, an achievement that demonstrated the practical power of replaceable units assembled into larger systems. Historical context: printing before Bishang. Prior to Bishang's innovation, texts in China were reproduced primarily through woodblock printing. In this method, an entire page of text was carved into a single wooden block. While effective for large print runs of the same text, woodblock printing had significant limitations. Each page required a new carved block. Correcting errors meant recarving the entire block. Storage of carved blocks was space-intensive. Production was laborious and time-consuming. In a society where literacy, scholarship, and bureaucratic administration were central to governance, particularly under the Song dynasty's civil service examination system, these limitations created strong incentives for improvement. The invention of movable type. Bishang addressed these inefficiencies by developing a method of printing using individual characters cast from baked clay. Each character was formed separately, hardened by firing, and then arranged on an iron plate coated with a mixture of resin, wax, and paper ash. Once arranged to form a page, the characters were heated to secure them in place, inked and pressed onto paper. After printing, the characters could be disassembled and reused for new texts. This system introduced several transformative principles. Standardization: each character was produced as a uniform unit. Modularity: characters could be assembled in countless combinations. Reusability: individual components were not tied to a single page. Replaceability: damaged or incorrect characters could be swapped without reconstructing an entire page. These features collectively embody the essential logic of interchangeable parts. Discrete components manufactured to consistent specifications so that any one piece can substitute for another of the same type. Conceptual significance: the birth of modular manufacturing. Although Bishang's system was applied to printing rather than mechanical devices, its intellectual significance reaches far beyond publishing. The core breakthrough was not merely technical, it was systemic. Instead of crafting each product as a unique whole, Bishang separated production into the creation of standardized components, the assembly of those components into final products. This shift from holistic carving to modular construction represents a foundational idea in industrial design. Later manufacturing revolutions in firearms, clocks, machinery, and eventually automobiles would rely on the same conceptual architecture. Centuries after Bishang, European and American industrialists such as Eli Whitney would popularize interchangeable mechanical parts in weapon production. Yet the principle of standardized replaceable units had already been demonstrated in China 400 years earlier. Practical impact in Song China. Bishang's invention did not immediately replace woodblock printing on a massive scale, largely because the Chinese writing system contains thousands of characters, making full sets of movable type labor-intensive to produce and manage. Nevertheless, the technology increased flexibility in text production, reduced the cost of correcting errors, laid groundwork for later advancements in metal movable type, demonstrated the feasibility of component-based production systems. Later improvements during the Yuan and Ming dynasties expanded upon his method, including the development of wooden and metal movable type. Long-term global importance. The broader importance of interchangeable parts lies in their role in enabling mass production, mechanized assembly, reparable consumer goods, standardized quality control, industrial scalability, transformational cost reduction. Standard components revolutionized manufacturing and production systems in general. In the modern era, Interchangeable parts form the backbone of manufacturing industries, from aerospace engineering to consumer electronics. Assembly lines, pioneered on a large scale by figures such as Henry Ford, depend entirely on standardized components that fit together predictably and reliably. Shang's innovation marks the earliest documented applications of interchangeable standardized units in human history. More than a printing technique, it represented a profound conceptual advancement. The realization that complex products could be built from modular components designed for reuse. This principle transformed not only printing but the very structure of industrial civilization. In tracing the genealogy of interchangeable parts, one finds that the roots of modern manufacturing extend back to 11th century China, where Shang's clay characters quietly introduced a modular logic that would one day underpin the global industrial economy.